The concepts that were discussed in the video were the concept of probability, sample space. Can someone tell me what is the definition of sample space? Should I call names?
Yes.
Antonio,
Yes.
can you tell me what is the definition of sample space?
Its sample space is similar to the sample space like in linear algebra.
You should have watched the video and you should know. Did you watch the videos?
Yeah, I forgot because I had other classes.
Can I answer, Professor?
Go ahead.
So it's basically the all possible outcomes of an experiment.
Exactly. So we run an experiment. The outcome of an experiment is not fixed, it's random. A sample space includes all possible outcomes of that experiment. For example, if I throw a coin, what are the two possible outcomes I can have?
Head or tail? Head or tails.
Exactly. So the sample space here is either head or tail. If I throw a die, what are the sample spaces? What are the values or possible values of the samples?
1 to 6.
All the way to 6. Okay. And then we also learned the concept of the event. Can someone tell me what is an event?
It's a subset of the sample space.
Exactly, it's a subset of a sample space. So in this scenario, when we throw a die, if I'm looking at the event, when the outcome is even, what are those possible values? I want the outcome when I throw a die to be an even number.
2, 4, 6.
2, 4, 6. So that's a subset of this sample space, and that's the event in which I expect the possible outcome of this experiment to be an even number. Okay, and then we also learned a couple of concepts with respect to the events. We learned the concept of the complement, union, intersection, and yeah, and then also mutually exclusive events. So, okay, let's assume I run an experiment and this set has all possible outcomes of that experiment. So this is the sample space S, okay? And then I consider some possible outcomes, A, some possible events. So this is a subset of this big sample space. I call it as A. This is B. And this is C. This is my question for you. Is there any intersection between event C and event B? Do they have any intersection?
No.
What does that mean?
They're mutually exclusive.
They are mutually exclusive. Can you explain one more time? What does that mean when we say two events are mutually exclusive?
It means there's no overlap between the events, that they can't coincide at the same time.
Exactly. That means these two events have no overlap, and there is no outcome of this experiment that belongs to event B and event C. So if I go back, maybe here in this example of a die, if I consider this as event A, and then maybe another one as event B, that are the odd numbers, 1, 3, and 5. So then we can say they are mutually exclusive, just because there is no intersection between these two events. Okay. Let's assume I define another event here, event C, and these are the members, 1, 2, 3. In this example here on the top, can I say that A and C are exclusive, mutually exclusive? Can we say that?
No, there is an intersection.
Yes, because 2 is an intersection between event C and event A. The outcome 2, if we run the experiment and the outcome is 2, then we can say event C has happened and we can say event A has happened. So they are mutually exclusive. So they are not mutually exclusive. So here, can you show in this figure that we just draw, can you also tell me 2 other events that are not mutually exclusive?
A and B.
Exactly. A and B are not mutually exclusive. And this is mainly because they have intersection. There is intersection between them. That's the part. So if an event happens and falls somewhere in this green area, then we can say both B has happened and A has happened. So they have intersection. So they are not mutually exclusive. C and B are mutually exclusive. And what is the other, how do we show this part, the A and B, this part that happens, that belongs to both A and B? How do we show this? We learned that in the videos.
A intersection B.
Exactly, A intersection B. So that's exactly the green area. So the intersection of two events are those outcomes that belong to both events, A and B. Okay, and then okay. How about the union? So if I say A union B, what does that mean?
All of A and all of B.
All of A and all of B. So if I want to shade the area, it's all of A and all of B. Okay, so that red area, that would be the union of A and B. And then the other term that you guys learned was the concept of complement. So this is C and this is the complement of C. So can you tell me what does this mean?
It's everything outside C.
Exactly, everything that is in S, in the sample space, but is not in C. Everything that is outside of C here. So that would be this whole orange area. That would be the C complement. Okay. Okay, so now let me ask you a couple of questions. So you guys remember this was B and this was A. Can you tell me what is C complement intersection B in this graph?
Is it just B?
That's just B. Because intersection B is the area that is shaded in orange. And then the B is just this area, right? So what are the events that are in both of them? Everything that is in B. They are in B and they are in C complement. So C in C complement intersection B is B. How about C complement union B?
C complement.
Equal to what?
C complement.
It's C complement. So everything that is in C complement, that's the area shaded in orange. And then everything that is in B all together. So C complement is basically the area because B falls in the C complement as well. So that would be the C complement. Yeah. Okay. Then I wanna solve a problem. Wait 1 second. Let me. Okay. So in this problem, let's assume we have been able to collect samples of the earthquakes that have happened before. And when we look at our samples, we can see that we can divide, we can look at the measure, the magnitude of the earthquake. And when we look at the magnitude of the earthquakes, we see that we can categorize them into low, moderate, and high. Okay. And then we can also, in these areas, or these are basically part of the roads for which we collect the data. So they have been affected by the earthquakes that have happened. And the magnitude of these earthquakes can be categorized as low, medium, or high. We have also looked at the level of debris that have been collected, have been accumulated on these road sections. The level of debris are either light or high. Okay, and then when we have looked at our sample, we have seen that 85 of them are in this category, 15 of them are in this category, 50 are here, 60 are here, and then 30 are here, and 70 are here. Okay, so so that's basically how our sample has been categorized. When we have looked at the road sections and we have looked at the level of the magnitude of the earthquakes that have happened on them and the level of debris that have been accumulated on them, we see that we can put them in these categories, and this is how many road sections have fallen in each category. So we can see that when we are looking at the magnitude of the earthquake, low or moderate or high, how many road sections I have that have been under effect of, that have been under the low magnitude earthquake? 100, right? How many road sections have been under moderate earthquake? 100. And how many road sections have been under high earthquake? 100. Okay. So what is the total sample size here?
Excuse me, the moderate is 110. 110.
Sorry, guys. I mean, I was hoping you are right, but no, that's fine. Let's keep it as 110. I was trying to put it under 100 so that the calculations are simple at the end, but don't worry. Okay, so 100, 110, and 100. So what is the total sample size here?
310.
310. 310 is the total number of road sections I have collected. I have looked at them. I have looked at the magnitude of the earthquake that has happened in them and the level of debris, and then I have put them in this table based on how many road sections have fallen in each category. But total sample size for me is basically 310. So this basically can be considered as my sample space. So these are all the possible roads that I have in my sample. And do I know the situation of earthquake in each one of them? I don't know exactly, but I know that potentially the level of magnitudes is in one of these three, and the level of debris is one of these two. Okay, now I'm going to define an event, and in this event A, I'm going to define it as road sections with low level of magnitude, low level of earthquake. Okay, and I'm going to define another one B, which is road sections with high level of earthquake. And okay, I'm going to define another event C, road sections with light debris. And okay, let's for now start with this. Can you tell me that how many members event A has? How many members belong to event A, which is a road section with low level of earthquake?
200.
100. So event A has 100 members. Can you tell me what is intersection of A and B? A and B means road sections that have
100.
Isn't it no?
Okay. Someone tell me, what does this mean? A intersection B. Just tell me in a sentence. What does that mean?
What they have.
Go ahead.
That they have a low level of earthquake and a high level of earthquake.
We have low level of earthquake and high level of earthquake. Is there any road section that has low level of earthquake and high level of earthquake? These are 300 different road sections, and we have looked at each one of them, and they have fallen in one of these categories that we see. So we do not have any road section that has low level and high level. So basically it's impossible. So when we look at each road section, we can put the magnitude of the earthquake in one of these categories. We can't put it in. So if it's low, it's low. If it's high, it's high. We can't say the earthquake magnitude is low and high. Okay. So basically there is no road section that falls in this category where we can say the level of earthquake is low and high. So there is no road section that belongs to this event A and B, and that is empty set or null set. Okay, that's how we show it. That's that. And then can you tell me how do you read this A complement? Tell me in a sentence.
Everything outside of A.
Okay, no, you're right, but first tell me in a sentence. How do you say how do you define the A complement?
Everything that's not low.
Exactly. A is the road sections, contains the road sections that have low level of magnitude. Then A complement are the road sections that the level of magnitude is not low. And what is not low here? If it's not low, then it's either moderate or high. So can you tell me what is the number of members or samples that fall in A complement?
210.
210. Everything that is moderate and everything that is that has high level of earthquake. Okay. Can you also do similar analysis for me for C complement? What does C complement mean? C is road sections with light debris.
C complement is all road sections that do not have light debris.
Okay, so then C complement would be all road sections that do not have light debris, and here the only other option is high level of debris. So that would be so every road section that would fall in the high debris will be the ones that fall in the C complement. And how many members?
145.
Thanks for calculating. 145, which is the sum of these numbers. And now tell me, what does this mean? A intersection C. Can you read that for me? In a sentence, tell me what does that mean?
You mean the answer?
Sorry?
You want the answer? Or?
Yeah, please tell me what is the meaning of A intersection C in a sentence. Answer that question.
Would it be road sections with low level of earthquakes and light debris?
Exactly. A and C, so this is A and this is C. So A and C, A intersection C means road sections that have low level of earthquake, and then intersection, which is and C, and this is C, and they have light debris. So tell me how many members I have in A intersection C.
85.
85. So those are the road sections that have low level of magnitude and light debris. So that's 85. Um, tell me what is A complement and C. First, tell me in the sentence what it means, and then tell me how many members do we have.
It's road sections that do not have a low level of earthquakes and light debris.
And light debris. Road sections that do not have a low level of earthquake and intersection, and C, they have light debris. And can you please tell me which elements of this matrix I have to add together to find the members in A complement C?
Would that be 50 and 30?
That would be 50 and 30. So because A complement is everything that is not low. If it's not low, is either moderate or high magnitude. So these two are in the A complement. And then and C, so C is this whole column, right? But then when I say and C, that means intersection of this part and the column C. And these two numbers, these two are the only ones that belong to not having a low level of earthquake and light level of debris. So that would be 50 plus 30. Also, tell me what does this one mean? Let me go back to black. A union B. How about this one? What does that mean?
Road sections with low level of earthquake.
Because you got disconnected for a second. Can you please repeat?
Road sections with low level of earthquake or high level of earthquake.
Exactly. So A or B, road sections with low level of earthquake, or union is or high level of earthquake. And what are the members? How many members do I have here?
Is it 200?
So road sections that have low level or high level. Both of them are acceptable. One more time, try one more time.
100.
200. The 100 are the ones that have low level of earthquake, and then 100 are the ones that have high level of earthquakes. So, and I want a road section that has low level or high level. So either from this 100 or this 100, both of them are fine. That's 200. Okay. And one more question before I let you go. I see that the time is up. If I ask you, what is the probability? If I ask you, what is the probability that when I pick a road section randomly out of this 310 road section, it belongs to A, meaning that it has a low level of magnitude of earthquake?
It would be 100 over 310.
Exactly. So there is 100 over 310. There are 310 road sections overall. 100 of them have low level of earthquakes. So if I just pick one road section randomly out of these 310, the probability that it ends up to have low level of earthquake is 100 over 310.